On Thursday's video, we will talk about two sections. The first one, we will talk about addition and subtraction. We will introduce more add and sub and increment and decrement instruction. Then we will talk about some data-related operator and directive. So the first thing, let's see about the addition and subtraction instruction. So the first one, we will talk about increment and decrement instruction. You already saw add and sub instruction, so we will further to talk about that. And also at the end of this section, we will talk about more in detail for how the status flag will be updated after the arithmetic operation. So remember, we have zero flag, sign flag, carry flag, and overflow flag. So they all have the definition we already talked about in the previous chapter. So if you have question about the definition, please make sure you will go over the previous chapter to see the definition. And also we have here as well. So then if you have any question, make sure you will write down. So during the Zoom meeting, we can go over that. So the first thing, that's the increment and decrement instruction. So that will be the INC and the DEC instruction. So they are using add only one or subtract 1 from the destination operand. So operand can be register or memory operand. So they can be register, they can be memory operand. So both INC or DEC, they only associate with one operand. So INC destination operand, they were using this operand to increment by 1, then you update this operand value. So that's the logic. So after you add by 1, we update the destination operand value. So the same thing, DEC will decrement minus by 1 from the destination, the original value, then the update the destination operand. So you can see here, we only limited to add by 1 or minus by 1. So that's the INC and the DEC. So let's see the INC and DEC instruction example. In the data, we define two variables. One is word, one is the word, and we assign the initial value. So you can see in the code block, we increment my word. So that means my word will be added by 1. So it was 1000. So added by 1. Afterward, my word will be 101. So then you decrement my word by 1. So of course, they go back to the original value. You can decrement a 2-byte memory operand. So they also can work on the 4-byte. So then my D word, if you increment, they will be added by 1 to the end. So you can work on INC or DEC on the memory operand. They also can work on the register. So that's why here we move the AX with the value 00FF. So after you increment the AX, so that's why you see FF plus by 1. So F plus 1, we carry over 1. F plus by 1, we carry over 1. So afterward, there will be 0, 1, 0, 0. So that's the AX. So again, we refresh, AX value becomes 0FF. So here you can see I overwrite 2-byte AX, right? But your INC and DEC, they can work on 1-byte, 2-byte, or 4-byte memory operand or register. So that's why here, if you're using the AL, you add AL, you only work on the last 1 byte. So that's why only AL. So you increment by 1, right? F plus 1, we carry over 1. F plus 1, we carry over 1. So they become 0, 0. So then the carry over 1, because one thing is you only work on 1 byte. So even the carry over 1, they won't be reflected. So that's why here you need to be careful. Here your AX still is 0, 0, 0 because you only increment AL. So earlier we only increment the FF. So then FF plus 1, they will become 0, 0. So the carryover one won't, because they have the AH in front of that to do that. Because your instruction, they work on 1 byte. They only can work on the 1 byte register. So one thing is, later we will talk about all your instruction. After you're done, you will update your status flag. But one thing is here, the INC and the DEC instruction, they won't affect the carry flag. Also be careful about that, because they only add by 1. So for us, we don't update the carry flag for the INC and the DEC. So continue to make sure you understand that. I want you to post the video. Usually in the class, we will do the peer talk. So that's why you were using the following example to see. So now here, I give you a byte array. So that's why you see you have 2 values. So then here, they can work on your AH, AL, AX. So now your job is to make sure you understand after the decrement and increment, your value change like this. Make sure you will work on that and check your answer. If you have question, make the note. We will talk about that in the Zoom meeting. So but your turn is you need to work on that. So INC and DEC are new, but here add and sub instruction, we already talked about that earlier. But here I just want to remind you again the restriction about the add and the sub instruction. Both add and the sub instruction, you work on 2 operands. So the first operand, of course, that will be the destination operand. The second operand will be the source operand. So when you add, we will add the source value to the destination, then we update the destination. So the same thing, sub, we will have destination and the source. You will subtract the source from the destination, then we update the destination. Before we only talk about this, but now continue, we talk about this week is for all the move, add, or sub instruction, they all have the rule. Also remember, like move, we told you the operand rule is both destination operand and source operand cannot be memory operand. Only one of them can be memory operand. And also they need to be the same size. So all the rule apply for the move instruction, they will apply for the add and sub instruction. Quickly, we see a couple examples about the add and sub example. So you see here we have 2 memory operands. They both are 4 bytes. That's the D word, double word. So we have val 1 and val 2. So so when we do the move, I can move val 1 to EAX because they both are 4 bytes. So then I can add val 2 to EAX because they both are 4 bytes. So that's why I see afterward EAX is 10000. So then add val 2 will be 3, then 40. So continue, you have EAX is this value, right? So remember, when you have your register, you can work add for the 4 byte with 4 bytes. But also we can just work on the last 2 bytes from EAX. So here I can add AX with FFF. So that's why you will see, where's AX? Yeah, here is AX. So AX only apply the last 2 bytes from the EAX. So that's why here is the AX. Then you add FFFF. Okay, so here they only update the last 4 bytes. So that's why after they finish, AX is FFFF. So then your EAX will be like this. Okay, so you can see add, you can work on different size of the operands, just as long as the 2 operands with the same size. So now if you say add EAX with 1, so so when we want to add EAX, I am working on the whole thing. So then I work on the whole thing. So then I plus by 1. So you carry over 1, carry over 1, carry over 1, so become 4. So then afterward your EAX become 4000. Okay. So then again, so here we want to sub AX, right? So you need to be careful. You sub, you only work on the last 2 bytes. So you subtract by 1, right? I carry over, then after I minus by 1 become FFF. I need to borrow from the previous bit, then subtract 1 become FFF. But one thing is, because you only work on AX, so that's why they won't really borrow from the 4. They only they borrow from the previous one, but they don't touch from the previous one. So here, this one is, later you will see the carry flag will be shown because they borrow from the previous one, but they only update the last 2 bytes. So afterward, you sub by 1 for the AX. This one will be your EAX. Make sure you understand how that works. So if you have any question, make sure write down. We will talk about more during the Zoom meeting. So the last instruction from this video, we will talk about the neg. So that's negative instruction. So the neg actually will reverse your sign from the operand. So they only reverse the most significant bit from the operand. So that's why you can know the neg actually is only work on one operand. So just like increment, decrement, the operand can be a register or it can be memory operand. So then we see the example. So here we have the data defined. We have one sign byte variable called val b. We have one sign word variable called val w. So then we assign the value. So then we move the val b, that's byte, to AL. So the AL equal to -1. So then if you neg your AL, so then they will become +1. So then here you have your val w. So that's a sign word, right? So that's 2 bytes. So then you have the value 32767. So then if you neg this value, they just change the sign bit. So then the val w will become -32767. Okay, so let's put the code in the Visual Studio to check the answer. So like earlier we say we have one signed byte variable. So then we have signed word variable. So we will see after we do the neg, the value did change or not. So of course we need to run from the debugging mode. So then from the watch, so then we will have the EAX value. But here actually since we want to see the we have the AL value, we also, so let's put the AL and the val W in there. So after we move the val B to AL, so then you will see the AL will become 255. But why is 255? Because one thing is, you remember, your AL actually is only the unsigned number. So now when you really want to see the value, you see the -1, they won't really interpret as -1 because here the type for the AL is unsigned. So that's why they will interpret that as 255. But one thing is, we see here, that's just interpretation. So here, one thing is, if that's a register, you cannot really change the value. So that's why they only treat them as unsigned. So you will see they say that's 255, right? But that's fine. You see, after we neg that's 255, you will change your signed bit. So then you see here, afterward, you see your AL did become 1. So that's why we say we feel like it's -1 become +1. But that's because we define as a sign byte. So when you move that sign byte equal to AL, the sign byte actually just represent they are all 1. So that's why interpret in the register, they will just interpret as unsigned integer, so that's 255. But when you work as the neg instruction, they will change the sign bit, the most significant bit. So that's why the value will become -1. However, now you see you have the SW is positive. So then we continue to see that. After we neg the negative the positive 32767 become negative because we define that it's a sign word. So that's why when they show, they will show you